moving on to our next speaker, although it's always hard to leave one and move on to the next. Our next speaker today is a developer, and he's also a technical lead, and his focus is on databases and software design, and his name is Haki Benita. Welcome.
Hi, Claire.
Did I say it right? Did I say your last name right? We didn't practice it. Oh my God, it's wrong.
No, you said it correctly. I made it easier for everyone because nobody can actually pronounce my real name. So Aki is like an alias.
It's okay. Well, I got to say, other than people from Italy, most people mispronounce this last name that I married into. So names are tricky.
Exactly. Names are tricky. This is why we all have handles, you know.
Exactly. So you're here today to talk. The title of your talk is Lesser Known Features of Postgres. You've obviously given similar talks in the past, and you've written about this topic too. I think it landed on the front page of Hacker News, didn't it? Or the very top of Hacker News. So I know it's popular. I know people want to hear from you. So I'm going to step back stage and let you take it on from here.
Thank you very much, Claire. Okay, so hi everyone. My name is Haki Benita, and as Claire said, I mostly am interested about databases and web development and software design. Aside from being a DBA, I'm also a software developer, so I get this perspective from both worlds. But I usually like to say that I'm a DBA that knows how to develop applications and not the other way around. So today I want to talk about a few lesser known features in PostgreSQL, but I would say this: I'm not going to talk about new lesser known features. I'm going to talk about lesser known features in general, meaning that even if you're not working on the latest or on a latest version of PostgreSQL like 13 or 14, there is things in this talk for you. I have features here that are in Postgres from Postgres 10, and not a lot of people know about them. So some of these features are actually undocumented, and when I will show undocumented features, I'm going to add a note because you should be careful with undocumented features. So let's start. I'm going to go fast, and hopefully we'll make as much as possible. So insert on conflict, also known as the upsert command, or if you're coming from a different database, you might know this as merge. It's a way of syncing data between two tables. Let's see an example. Say that you have an employees table, name, department, role, and the salary. And now you want to sync new employee data into the employees table, right? So if we take a look at the data, we can see that George is an existing employee, and we just updated his salary. And Jane is a new employee starting in the R&D department as a developer. So now we want to get this new employee data into the employee data. We want to sync it. This is a very common thing to do in ETL processes or data migrations and so on. So if we want to do that in Postgres, what we can do is we can use the insert command, just like you are familiar with, but we might have conflicts. Remember, George is already an employee, so we can't insert George again into the table. So Postgres provides us with an on-conflict clause that we can tell the database what to do in case of conflicting name. So in this case, in case of a conflict on the name column, we want the database to do an update. So if the database encounters a row that already exists in the table with the same name, it will update the department, the role, and the salary from the table we are inserting from. In this case, new employees. So this is very useful, and this also assuming that name is unique, okay? So if we look at the output of this command, we can see two rows. The first is George and Jane, and Postgres tells us that two rows were affected. But the question now is, how many of these rows were updated and how many were inserted? Okay, so if you have an ETL process or a data migration, this might be information that is useful for you for logging and stuff like that. So I want to show you a little trick of how to achieve this. So this is using a system column that I'm going to explain in a bit, but I haven't found much reference to it other than that. So be careful with that. You can use that for logging, but maybe not something that relates to the actual business logic of the process that you are implementing. So a possible solution. We take the exact same command that we ran before, insert, and on conflict do update. And if you'll notice at the bottom, the highlighted row, we want to return the data, return and a star, centric. We return all the data that were affected by the query. And we also add an expression, xmax equals 0. Okay, so if we look at the results, we can see that now we have another column called inserted. And this column says that for Jane, the row was inserted, and for George, the row was not inserted, meaning it was updated. So now we know how many rows, which rows were inserted and which rows were updated. And we can actually aggregate on these results to produce a useful log. So how is this trick working? Remember that we use the special column called xmax. So xmax is a special identity column in Postgres. And if you're not familiar with how Postgres works, when you update a row, Postgres behind the scenes deletes the current row and inserts a new one. So xmax is the transaction ID of the deleting transaction, meaning if we executed an update, then we are going to have the transaction ID of the deleting transaction. However, if we inserted a new row, then there is nothing to delete and xmax is going to be 0. So this hack is building on this behavior by Postgres and calculates an expression that lets us distinguish between inserted and updated rows. Very cool, very useful. I used it several times myself. So next up, sleeping. Anybody with babies at home has to appreciate sleeping. So why would you want to sleep? There are many reasons that you want to sleep during the execution of a program. Sometimes you want to do some benchmarking. Sometimes you want to do testing, maybe throttling some to control access to some resource. Maybe you have some while true. Maybe you're just doing some benchmarks. There are many ways to sleep and many reasons to delay the execution of a program. So if you ever had to sleep in Postgres, you probably used PG sleep. It accepts a number, which is the number of seconds you want to sleep. If we set up timing and select PG sleep 3, we can see that the execution took 3 seconds. So for 3, it's not that bad. But what if we need to sleep for a longer period of time? So in this example, we want to sleep for 255 seconds. So how long will this function sleep for? So before you take out the calculators, if you want to be a good friend, if you want to be a good developer, good teammate, you can change it to write it like this. So 4 times 60 plus 15. This makes it a bit easier to identify that you want to sleep for 4 minutes and 15 seconds. But if you want to be a very good friend, you can actually use PG sleep 4. This is a relatively new function that accepts an interval. And I don't think it gets any simpler than that. So PG sleep for 4 minutes and 15 seconds. That's basically English. Okay. What happens if you want to match against multiple patterns? Let's look at an example. Say that you have a users table and you want to find all the users that use a Gmail account. So that's a fairly straightforward query. You just query from the users table and you match against strudel gmail.com. You can use the percentage sign to match against everything. So this expression will match against anything that ends with gmail.com. So that's easy. But what if you also want to find users that have a Yahoo email account? So now you add an or condition with 2 patterns, and your predicate gets a bit more tricky. The more pattern that you add more or conditions and the predicate gets more and more complicated. So there are a few ways you can make this a bit more readable. Let's see some of them. So the first approach you can take with Postgres is using the similar to operator. This lets you provide a pattern, and the pipe operator can match against multiple patterns. Okay, so this is using POSIX regex, and it's pretty clear. Another option is to actually use regular expressions. In this case, there is something tricky that you need to know. The period matches against any character. So if you actually want to match a period, you need to use an escape character, in this case, the backslash. So that's also another way of approaching this problem. But another very cool way in Postgres, and if you're using Python, you might be familiar with any and all. So Postgres also provides a way of matching against an array of patterns. So this condition will match email against any of the provided patterns. So what is the benefit of this approach over the other approaches? If you are executing this query from some host language like Python, this is an example using scopg, which is a driver for Python, then you are probably using bind variables. So it's much nicer to be able to send a list of patterns instead of just a big pattern. So in this case, you can see that we bind an array called patterns, and we actually provide a Python array as a bind variable to this query. So that's pretty nice. Keep that in mind the next time you need to bind or match against a list of values from a host language. Okay, generate reproducible random data. This, I know that it sounds strange. Why would you want to reproduce random data? And if it's reproducible, why is it random? I'm going to try and explain. So let's say that you are giving some code review to your fellow developer, and you think that some of his code is not 100% optimal, and you want to demonstrate to him why. So you set up this sample table, you populate it with a lot of random data, and then you execute some queries to make your point. That's fine. And then you send your fellow developer the script, okay? And he tries to execute it on his workstation, and he gets different results. So that's now good. That's very confusing, okay? So let's see an example of how we can make my fellow developer produce the exact same data for testing and benchmarking. So this is an example of how you produce different types of data types in Postgres using the random function. You have a random float, integer, and date, and you can see the results below. If I take the exact same query and execute it again, I'm going to get different results, right? Because it's just random. But if I want to make sure that when I re-execute the same script again, I'm going to get the exact same results, meaning reproducible random data, I can use setSeed. setSeed accepts any value between 0 and 1. And when you use setSeed at the beginning of the session, consecutive calls for random are supposed to produce the same values. So if you actually have PSQL open in the background, you can actually setSeed 4050 and execute this query, and you should get the same values that you see here in the presentation. Okay, just to illustrate, if I set the seed and call random to produce two random floats, and I take this to a different console window or even execute this on my server, I'm going to get the exact same results. So this is very useful if you are demonstrating something, benchmarking something, testing something. I know that usually when I write in my blog and I want people to be able to reproduce my results, I always include a setSeed at the beginning of the script. Okay, so now we have the feature with the best name ever, $quoting. And this is what it does. So let's say that you have this string constant, in this case, John's Pizza. This is just the name of a business. And you might notice that John's Pizza has a quotation mark right before the S. Now, if we want to include that in the output, we need to escape that. In the case of a single quote, I need to escape it with another single quote. Another type of annoying characters that you need to escape are new lines and backslashes. So if you want to add long strings or complicated strings in PSQL or in SQL in general, it's pretty annoying. So I didn't know that for a long time, but there is a solution for that in Postgres, just like in any other language. So another way of writing string constants is using what's called dollar quoting. If you look at the query that you see on the screen, you might notice that you have $2 at the beginning of the long string with new lines, and then you have another $2 at the end. So everything between these $2 is a single string. You can also notice that we have single quotes and double quotes and many different type of characters and new lines and so on. And everything between these $2 quotes is a single string constant. So that's pretty useful. No need for escaping. Now let's make this harder. What if I actually do want to include the $sign in my text? In this case, I want to add a string constant with a JSON value with a tagline for John's Pizza saying best value for your $sign. Okay, so if I use $sign, Postgres might get confused and terminate the string just at the end of the tagline. But I don't want that, so I can actually use a different token. So in this case, I just made up a token called JSON, and everything between $JSON, $sign until another $JSON, $sign is a single string, and you can see the output below. So that's also very useful. One of the best uses I found for that is when you have some big JSON file and it actually makes more sense for you to process it in the database. You can just cast this to JSONB and continue processing in the database. This is very useful. And I know that you talked about it in the previous talk, but Postgres is doing an amazing job with JSON types, where it came to a stage where it actually makes sense sometimes to paste large JSON data into the database just for processing using Postgres. So this dollar quoting makes this especially easy. Okay, so that's a fun one. Let's talk about how to prevent setting the value of an auto-generated key. So if you are old enough, you're probably familiar with the serial data type. If you have a primary key in the table and you want to populate it from some sequence, you might define it like that: ID, serial, primary key. Okay, so Postgres in this case will create a unique constraint and also create a sequence behind the scenes to use when you add new sales into the sale table. So this serial data type is very unique to Postgres. It's not standard SQL, and it has a lot of known problems, which I'm not going to talk about. So starting at Postgres 10, the team decided to softly deprecate it in favor of identity column. And this is what it looks like. Instead of writing serial, you write generated by default as identity. So this works very similar to what you know from a serial data type, but it's SQL standard and it solved a lot of the problems of serial. But let's consider this scenario. Say that you are adding a new cell to the table and Postgres uses the sequence, populates the ID with the first value 1. Great. Next, you add another cell into the table, but this time you provide a value for the ID column. You provide the value 2. The statement succeeds and you have 2 rows in the table. Next, you try to insert a value into the sale table, but this time you do not provide a value for the ID column and you get a unique constraint violation. So why did it fail? When you added the first row, Postgres used the index and set the value 1. When you added the second row and provided the value 2 for the ID column, the sequence was not used, so it was not advanced. In the third command, when you did not provide a value for the ID column, Postgres used the index. The value happened to be 2, and you got a unique constraint violation. So if you think about it, it doesn't make a lot of sense to set values for auto-generated keys. And as we saw, it can cause a lot of mess. So is there a way to prevent that? Is there a way that we can tell Postgres, stop, do not let the user set a value for this column? And actually there is. Instead of defining the identity column as generated by default, we can say that it should be generated always. If we try to do that again, provide a value for the ID column, we are going to get an error. Now, Postgres is nice enough to tell us what we need to do if we actually do want to set a value for this ID column. We need to use this option called use override system value. And this is what it looks like. So I think that's a good compromise because it allows you to set values explicitly, but you have to be very aware of the effect on that, on the potential effect of that on your system. Okay, so let's talk about constraints. So constraints are good. Constraints are great. Use constraints. Constraints keep data clean and reliable, and you should always use constraints. What I do like to say about constraints is that constraints are very easy to remove, but are very hard to add to existing tables. If you did find yourself in a position where you had to add constraints to an existing table, this can be a bit challenging. So let's look at an example. We have a very large orders table, and we want to add a check constraint to make sure that the price is greater than or equal to 0. If you look at the timing, you'll see that it took 10 seconds in which the table was locked, okay? So that's a bit of a problem. So is there a way to make this a bit better? There is. If we take a step back and look at what the database is actually doing when we are adding new constraints, it operates in 2 stages. The first one is to add the constraint to the table and enforce it for new rows. And the second stage is to validate this constraint for all the existing data in the table. So what if we can actually split this process manually? So you can. If you want to add constraint without validating existing rows, you can use this command, table add constraint and add not valid. Notice that it's very, very fast because it's only adding the constraints and starting to enforce it for new rows. Okay, so the next step is that we want to validate the constraint for past rows, and you can do that with table validate with the name of the constraint. I feel like I'm out of time, right? No, I think that I have a few more minutes left. I'm just going to go until they will shut me down. I have 3 more minutes. Great. Okay, so I won't talk about synonyms in PostgreSQL because that's very long. So you can read the article because I do want to focus on the PSQL tips because they are very cool. So this is one of the things that I found, and ever since I've been using it all the time. Let's say that you have this query on an employees table and you want to count how many developers, managers, and whatever you have in each department. So that's a very nice table with a very standard query, but a pivot table would be very, very useful for this type of information. So what you can do, and check this out, you can just use this command /crosstab view, and Postgres will just transpose the last results into a pivot table. So that's amazing. I don't know how many of you are using PSQL on a daily basis, but I do a lot, and that's amazing. You can actually control crosstab view with arguments if you want to transpose it in a different way. So crosstab view works on the last query results, and it uses the first 2 columns. So that's super great. You can use that. And my last tip, probably the most useful one, is copy. If you ever had to get data in and out of the database, you're probably familiar with the copy command. What you probably don't know is that there are 2 variations of copy. You have the copy command, which is executed on the server, and you have the /copy command, which is actually a PSQL command with a very similar API, only it's executed on your computer, on your client. So what you normally want to do is you want to use the /copy PSQL command because you want the data, you want the exported file on your workstation. The problem with /copy is that it does not support multi-line SQL. If you have a very big report, you can't use copy because once it detects a new line, it throws a parse error at you. But there is a trick you can use because while /copy does not support multi-line, copy does. So we can combine a few things together to be able to export multi-line queries to our local workstations. And this is how it goes. First, you use the copy command. Remember, that's the server command. Now, instead of streaming the results to some directory on the server, you can tell Postgres that you want to stream the results to the stun.output to std_out. Okay? And then you can combine that with the /g command, which is a PSQL command that writes stud_out to a local file. So this is how we can use copy and /g to produce the results of a long multi-line query to our local workstation. In this case, I use the CSV format. So this is it. If you like these tips, you can find the original article here at the top, lesser known Postgres features, as well as other similar features on my blog. And you can find me in all of these places, Twitter, get an email when I subscribe, when I publish something new, or if you're old-fashioned, you can send me an email to this address. And this is it. I hope you find these tips useful. Any questions?
Yes, that was fabulous. Thank you so much, Haki. I think you gave us a little teaser. There's a bunch of people chatting on Discord now saying what they really want to hear about are synonyms in Postgres. So it's the part you didn't talk about.
I know what they want to hear about synonyms in Postgres because synonyms does not exist in Postgres.
Got it. The other quote I wanted to read to you is like one of the smartest people I know basically said that he only knew one of the things that you talked about. So,
Really?
and he's super knowledgeable in the space. So I guess these are lesser known techniques. How do you come up with them? Why do you know these things when others don't?
I'll be honest with you, many of these features I came to find when I actually had a problem that I needed to solve. And some of them I found by just occasionally reading the documentation. You would not believe how many games you can find the documentation. A lot of good stuff there. It's a recommended reading if you are bored or have some time.
Now, which of the lesser known features have you found amongst all these things to be the most useful for you?
Great question. Aside from the copy command, which was an absolute lifesaver, I think that dollar quoting was the most useful simply because it's so obvious that there's something like that should exist in the database. And yet I spent so much time manually escaping strings in Postgres. Mm-hmm. And this was definitely a huge time saver for me.
Yeah. And I guess at the end of the day, time is probably what we all care about the most. Before we go, because it's about time to hand over and move on to the next talk, is there a new feature that you are most excited about?
Yes, absolutely. So at the beginning of the talk, I talked briefly about using insert on conflict, which if you ever written ETL processes or data migrations, you probably use all the time. So there is a limitation to on conflict at the moment. You can only upsert when you have conflict in a unique constraint, and you can only handle one unique constraint.
Okay.
So in Postgres 15, there's a new command called merge.
Yes.
And merge is supposed to solve both of these problems. You will be able to handle conflicts on non-unique columns, and you would also be able to handle multiple conflicts on different fields. So I'm very excited about that. I think it will be immediately useful for me.
Well, and I think the PG15 beta candidate release, didn't that freeze happen last week? So the folks who are Postgres committers are pretty exhausted still, still recovering from the whole experience. And I guess beta is going to be released for testing and whatnot in May sometime. That's what I'm hearing at least. Okay, so I want to thank you very much for joining us and being part of Citus Con. And I hope you keep blogging and sharing all your tips, especially as you come up with new ones.
Thank you so much, Claire. It was great. I'm going to hop on the Discord channel and answer some questions.
Awesome. That would be great. Thank you, Haki.